Hello, everybody, and thank you for joining us for episode 2 of our GraphQL Real-Time Race workshop. My name is Blaise Pele. I will be guiding you through this second session, second lab, and maybe day 2 for you of this workshop, where we will be focusing on GraphQL. And specifically, we are going to talk about API modernization with GraphQL. So, as I mentioned in our first session, this is the GraphQL Real-Time Race workshop. It's a workshop where we are implementing an application from scratch, an application that will help users interact with their race events, with live events, with data that is coming from the racetrack that will help users navigate around a racetrack and get more information about race events that are going on. So again, we are focusing on specifically on, we're looking at a lot of services, but we are going to focus on things like AWS AppSync, AWS Amplify, and Amazon Location Services. So the agenda for today, we are going to review objectives. Again, we'll look at the architecture, what we're building, some of the tools and services that we've got set up, and we are going to also talk about the code and discuss what's involved. So this is session 2. Again, this is the API modernization with GraphQL, and we're going to build on top of what we did in session 1. So from session 1, you should have your application launched and ready to go. You use data store in that session, and we are going to do some more work with GraphQL in this lab. The prerequisites and housekeeping, just in case you need it, it's on the screen. If you're joining us today and you want to do some of this work, go back and look at what we did on lab 1. Make sure you've got your AWS account set up. Make sure you've got a web browser and that you know how to navigate around the AWS console. Okay, so what are we going to build today? So as I mentioned, we have a lot of different services that we're using across this lab, but today we are specifically going to focus on using AWS AppSync and using AWS Lambda. We are still going to be working within the confine of an AWS Amplify project. Amplify is helping us deploy our resources, and then it's helping us connect our application to our resources into cloud. We've also deployed our application using the AWS Amplify console, so we actually have a URL, and you have a URL that you can share with other folks and have users use that URL to sign up and to sign into the account. And one of the things that we're really going to focus on today is interacting with data in DynamoDB. So in our first lab, and you can see the link for the lab here, all of the instructions are at this website. So you can go to this website to get all of the instructions and to follow along. In our first lab, one of the things that we did is we implemented a brand new application, and we started with some new set of data. But sometimes there are use cases and situations where you're not really starting with a new sets of data, right? Maybe you are migrating an application or migrating some features from an existing application to a new application, and those features relied on data. And you're looking to modernize it or improve the way your application behaves, right? A lot of times what we see is customers are looking to move from REST APIs to GraphQL API. If you're not familiar with GraphQL APIs and how they differ from REST API, maybe showing you a quick example of what traditionally happens with REST versus what happens with GraphQL will help. So in a REST API, you have, you may have a single API, but you have multiple URIs, right? If you have an application where you have posts, comments, and authors, you typically have to make multiple requests to get the information about your posts, comments, and authors, right? You are retrieving resources from this RESTful API, and you're making individual queries to these resources to get the data. In a GraphQL API, GraphQL is different. With GraphQL, you have a single endpoint, and you make a single request to get all of the data that you need. Because of how GraphQL is designed, you can also specify the data that you need, and you always get back only what you requested. So this allows you to improve and to improve the way you fetch data and to optimize the way you fetch data depending on the various scenarios that you may be implementing for. So using GraphQL is cool. It's really amazing. But when you want to start using GraphQL, you've got to think about how am I actually going to implement GraphQL. So this is why AppSync comes in. AppSync is a fully managed GraphQL service that allows you to deploy GraphQL endpoints into cloud. So AppSync is really cool. There's no infrastructure to manage. It's simple and secure to use. You can build real-time functionality, as we'll be looking at in this lab. And again, there are no servers to manage. So with that being said, what we're going to do in this lab is actually implement some resources using GraphQL and using AppSync. So, without any further ado, let's get to it. The first thing we're going to want to do here is launch our Cloud9 IDE. So I've got the IDE that I used in the last session. I'm just going to do Open IDE here. And so what can happen with Cloud9 is if you are idle for more than 32 minutes, it's going to automatically stop the EC2 instance that it's running on. And so this allows you to save money. And if it's not being used, you might as well stop it. So I'm just kind of reconnecting to my EC2 instance that is being used for Cloud9. And you can see here that it's reconnected. So that's great. And what we're going to do for this lab, we are going to work on lab 2. So we did lab 1, we're going to pick up things at lab 2, really focus on the modernization here. So what we want to do is start with an existing data set and implement on top of that. Let me restart my server. Just going to use yarn start. I'll go to another terminal here. I can do an amplify status to quickly see where how things stand, where we left off. My server is starting. Okay, and you can see the last thing we did, we deployed our API using data store. We deployed our auth using data store, and we also deployed our hosting resource to host our website online. And we can actually see the link here. So I'm just going to click on this, open. You can see everything is here. I'm already signed in. Let's go to my events. You can see that I can see my events here. Can still interact with it. So everything's good. Let me close some of these tabs. Okay, so because we want to work with existing data, let's go to the first section of the lab. We are going to create a new DynamoDB table, and we're going to import some data to it. So what we want to do in this lab is we want to be able to show information about racing events from previous seasons. So we're in 2021 right now. We want to show race information from 2020. So think about an application, backend resources that you may have where you already have that data set that exists today and you want to connect to it, right? When we did the lab 1 with data store, we created a brand new data set and then we connected to it. And data store made it really simple to connect to it. We didn't even really have to think about how that was happening. Now we want to use an existing data set and we want to use GraphQL as our API for our clients to interact with, and we want our GraphQL endpoint to retrieve that data for us. So to do this, we are going to set up a new DynamoDB table. So we're going to treat this DynamoDB table as our existing data set, and we can use Amplify to help us do that. So Amplify is pretty flexible and it helps us. It can actually deploy storage resources for us. So let's do that. So what we want to do here is add storage. I'm going to refresh the screen. So the first thing we want to do is add storage. So I'm just going to follow the instructions. So I'm going to do amplify add storage. And what we want is a NoSQL database. So that's going to be a database backed up, provided by DynamoDB. So what do we want to name this table? We're just going to name it race results because we want to see the results from races from previous years. Okay, you can now add columns to your table. Okay, and we're going to go with some generic names for some of these columns. So PK for primary key, and it's a string. Do we want to add another column? I say yes. SK for secondary key, and that's also going to be a string. Do we want to add another column? Yes. Driver ID. That's also going to be a string. Do we want to add another column? Round, so as in, what round of the championship, if it's in round 1, round 2, or round 3, and say number. And I think that's it for columns. So I'm going to say no. Okay, so now because we're setting up DynamoDB, we need to set up the partition key for the table. And the partition key, I want it to be the one that I set up here, PK. Do I want to add a sort key? Yes, here it is, the sort key. Okay, then it's asking me, do you want to add global secondary indexes? And we're going to say yes here. So essentially, DynamoDB allows you to configure global secondary indexes so that you can query your data in different ways. So when we want to get information about our races, we're just going to query it using the primary index. When we want to get information about our results for individual drivers, we're going to use another index, and we're going to query using the driver ID. So I'm going to name this. Do you want to add? Yes. Provide the GSI name. It's by driver GSI. And here, the partition key is going to be driver ID. And we're also going to add a sort key, which is the round. And what the sort key will do is it will allow us to return our data in a sorted order. So when we return race results, they're going to be sorted by the round. Do we want a Lambda trigger for the table? No. Okay, so that's everything. Let's see, what are the next steps here? Okay, so then we just want to push this. Okay, so again, here, Amplify is going to deploy those resources for us. So again, we went through this kind of a guided approach with the CLI, where the CLI asks us a series of questions, and based on our answers and best practices, it configures the resources on our behalf and deploys it using CloudFormation. Okay, so that's going on. While that's going on, I'm going to come in here, AWS Amplify. Okay, so let's give this a couple of minutes to deploy. Okay, it seems like we're just about done. So let's just do an Amplify status here. And you can see we've got our storage set up. One of the things that we can do as well, if we're curious, we can just go to DynamoDB. Go to tables, and you see we have our table here. And there are no items here, of course, because we haven't put anything into the table. So the next part is to actually load data into the table. So let's copy this, copy link address. Second here. Okay, and I'm going to do get. Yep. So essentially, this is a script that contains a whole bunch of data, and we're going to use this script to essentially seed our DynamoDB table with data. So here, if you don't have wget installed, you can run sudo yum install wget, but wget is already installed on Cloud9. So all I'm going to do is grab these. So I'm going to unzip it, and then I'm going to remove the script. So you can see if we go to where the script is, there's a file that essentially looks at the information in these JSON files, and you can see there's some result information, there's some races information, there's drivers information. So for example, you see this driver here. So we can store alter driver information as well. We can store results, like what happened in round one. In position one, we had a driver with driver ID Botas that has number 77 that was in position one, and so on and so on. So we're going to use our script to load this into DynamoDB. Okay, and to do that, we need to install the AWS SDK. So we're going to use the DynamoDB client into AWS SDK. So let's just add that as a dependency to our project. Okay, awesome. Okay, and now the next step is to actually jump to that directory, make sure we specify the region, which is US East 2, the environment, which is staging. And you can, by the way, get all of this data by doing amplify status, right? So you see the environment is staging here. You see that we're in US East 2. And the name of our table is race results. If for any reason you change something into script and you want to run the script or anything like that, you can always use these environment variables that we're passing to the script to change the behavior. But we don't need to do that for this one, so let's just run the script. It's fairly fast. There's 340 rows, about like a bit less than 400 rows. So not a ton of data, and it does it pretty fast, but it's a good amount of data, but loading data to DynamoDB is really fast. So DynamoDB is really efficient. So you can go here in DynamoDB and kind of see all of the data that's here. You see that we have 2 indexes. We can do a query. And if we want to get information about our drivers, for example, well, we can just say, hey, give me the information for our drivers. But we can also use our global secondary index to get race results for a specific driver. So you see all of these races here in 2020, round 1, 2, 3, and so on, and you get the position. So this driver participated in all these races, and here are all the positions that they were in. And then we have all of the information, the details about exactly what happened in that race for that specific driver. So pretty cool. All right, so we've got all of our data in our DynamoDB table. So now the next step that what we want to do is we actually want to update our schema. So this is not something that we really had to do a ton of when we were using data store. When we use data store takes care of, abstracts all of that work and takes care of provisioning a schema for us. If you are not familiar with GraphQL, GraphQL is a query language for APIs and a runtime for fulfilling those queries with your existing data. So the way GraphQL works is you start by creating a schema using the schema definition language that describes your data, right? You can see that here. You've got a schema that describes your data. And here, for example, I'm describing a project that has name, taglines, and contributors, right? Then, because I've defined my schema, I can then query for what I want. So I ask for what I want, and you can see that I have a query here that's asking for a project of name GraphQL, and that's asking to return the tagline. Notice that I'm only asking for the tagline, even though there are other fields that make up this project. And because I'm using GraphQL, it only returns the information that I asked for, right? It only returns the tagline. And this is really important and a real advantage of GraphQL, because we only get the results that we want. So they're not only are they predictable, but they're also really efficient, right? You could have a type that is made up of hundreds of fields. And if you're using something like a traditional REST API, you don't really have the opportunity to say, well, I'm interested in this specific type, but I'm only interested in 2 fields from that type, right? Then it takes a lot of time to retrieve the data, to send it over the wire, and it adds latency to your queries. So one of the advantages of GraphQL is that you get to ask exactly for what you want. And then AppSync essentially implements some of these requirements for GraphQL. So when you use something like AppSync, you start with the query language for APIs, right? So that's the definition of GraphQL. You can have your queries here. So for example, if I wanted to sync my post, I'd be able to do that. So this query is sent to AppSync, which implements a GraphQL endpoint, and AppSync essentially implements the runtime to fulfill those queries, right? So you need to be able to have the query language, but then you need to fulfill those queries. And then to fulfill those queries, AppSync introduces the concept of resolvers. And resolvers is essentially the glue logic that links your AppSync request to your existing data in your account. So now we've covered the three parts of the GraphQL definition: a query language for APIs, a runtime for fulfilling those queries, and allows you to access your data. So this is what AppSync does for you, and it allows you to specify your business logic to translate these requests into specific queries that go to your backend resources. Okay, so let's go back to what we were doing. So the first thing we're going to do is update our schema. We're going to add a type race and a type query to our schema. So let's go back into Cloud9. And to find the schema, it's in Amplify, Backend, API, GraphQL, real-time race, and just look for schema. Okay. So here, we're just going to add this. So you can see that we have the models that we've been working with from Datastore. So Datastore configures those models. So we're going to leave these alone, and we're just going to add the new type that we want, based on the definition that we gave it. And then we're going to add a query that we're going to implement that allows us to return all of those races. So make sure we save that. I'm going to close it for now. Okay, and then we need to implement those resolvers. The resolvers are the business logic that translate those incoming queries into requests that we can make to our backend data sources. And our resolvers are written in a language called VTL, Velocity Template Language. So we're going to do that now. We're going to implement those resolvers. And so you have a request resolver. So it takes the query coming in and maps it to a query that goes to your backend resource. And then you have a response resolver that takes the response from the query you made to your backend resource and transforms it into something that you can send back to your clients. So let's do that. We're going to go into API GraphQL real-time race resolvers. And in here, we're going to create a new file, and we are calling it actually query races rec VTL. Wait, how do I rename? Yep. Good. Then I'm going to copy this, put it here. And I'm going to do the same thing for my response resolver. Save this. Okay, and so now because we're adding these custom resources, what we need to do is actually update our CloudFormation template. Remember, Amplify uses CloudFormation to deploy your resources. I need to update my CloudFormation template to do a couple of things, right? We want to set up a new data source that connects to the DynamoDB that we set up. We want to create a new role that allows AppSync to access that table, right? So these are different resources, right? AppSync doesn't have any permission to access those resources unless you specify it. So we need to add that permission. And then we need to create the resolver with the above request and response template. So to do that, I'm going to copy this, and I'm going to look for the custom resources.json file. It's the confirmation template. And in my resources section, I'm just going to add a new set of resources. So I'm adding a couple of things here. Just do this. So I've added a race results data source role, the data source itself, and my query resolver. And if you look at the query resolver, you see that it's referencing, for its request mapping template, it's referencing the resolvers that we just specified. And so what Amplify is going to do, it's going to grab all of the data, all of the files that are in here, and put it in a deployment S3 bucket, right? And then we can refer to those assets, those S3 assets in our template here by specifying it in this way. Okay. And now that we've done that, so we've modified our custom resources, we've added the resolver templates. Let's push this. And again, this will take a couple of minutes to deploy. Now, while that is deploying, let's take a few minutes to look at what's going on in our VTL. So this is Velocity template language, but we can explain fairly simply what is going on here. So this is the Velocity template that's going to get called once we make a query. And the operation that you can see here is it's going to, and remember, so this is going to interact with our DynamoDB table. So we're going to make DynamoDB queries based on the data that's coming in. So the operation that we want to make against DynamoDB is a query. And then we specify the content of the query. Here, we're essentially telling it, well, the expression that I want to run is make sure that my primary key matches a certain value, and make sure that the sort key begins with a certain value. And this is static data, but we're essentially telling it we want the partition key to be race -2020, and we want everything to start with info. So this is returning the information about the races that happened in 2020. So fairly easy, and then we're saying, well, don't return more than 100 items. So we set the limit at 100. Yep. And then in the resolver response template, again, fairly simple. We're just telling it, well, return to items. So the cool thing about AppSync is it understands the data that's returned from DynamoDB. It's just an array of items. And then we can just return the response as JSON. And when you return JSON, AppSync is essentially going to map the fields to the type. So this response is expecting an array of races. Let's see again what we have into schema. It's expecting an array of races. So it's just going to map our list of items to the race, and it's going to map the PK, the SK, the race name as it got them from DynamoDB. So we don't really have to worry about mapping to data. Okay, awesome. All right, so now that that's done, the only thing we have left to do is update our page. And so for this lab 2, we are going to focus on our account page. So we have all of the code here, and you can definitely take some time to review it, but let's paste this in. I want to go here, account.tsx. Put it in, and let's take a look at what we get here. Okay, awesome. So you can see that we're getting the list of our races from DynamoDB table. So this is the 2020 schedule, and there were 17 races that happened across the globe. You can see the event information, you can see the track information. And this kind of shows you how you'd be able to get all of this information from an existing data source using DynamoDB. There's a lot of different information that we want to get, but we can use GraphQL and we can use DynamoDB to only get the data that we want, whether or not it's in one table or across multiple tables. Okay, so that kind of concludes this part of the lab. Let's move on to the next part. So what we did in this lab is we used VTL to connect to our DynamoDB table. There are also instances where you may not want to use VTL to connect to your data sources. You always have the option of skipping VTL, and you have the option of using Lambda directly as your business logic to connect to your data sources. In this situation, we talk about direct Lambda resolvers. So direct Lambda resolvers allows you to tell AppSync, use this Lambda function, don't write any, there's no VTL to write, fetch me the information that I want. So using a direct Lambda resolver is a great option to use if you have very complex scenarios where you need to fetch a lot of data sources from a lot of different data sources, or you just have a complex business logic that you want to implement in your language of choice, and you can do that in the Lambda function. So let's deploy direct Lambda resolver. So the first thing we're going to want to do is update our schema again. So now we're going to update it to get result for, right now we have race information, but we don't have any results. So we need to fetch more data from our table to get those results. So what we need to do is update our schema, and we're going to get our results. We're gonna have information about the constructor, the driver, the lap time, the speed, and so on. And then we're going to introduce this new query, get results for a specific driver, and then we're going to return to result for the driver. So let's do that. We copy this, find my schema. Now here, you can only have one query type, so make sure to not have two of them. What you can do here is just delete this and paste the rest of it. So you see get races is still here, and then we're introducing get results. Save that. Okay, then we want to create a Lambda function. Luckily, Amplify makes it really easy to create our Lambda function. So we're just going to follow the steps here to create this function. Make this smaller. Okay, and we're going to do add function. It's a Lambda function. The name is race results resolver. We want it to be Node.js. We're just going to use the hello world template. Do you want to configure advanced settings? Very important. We want to say yes here. Do you want to access other resources in this project from your Lambda function? Very important. We want to say yes. And what we want to do is select storage by using the tab bar. And the main thing that we want to be able to do here is access race results. So select that. And then what we want is to, let's see here. What operations? We only want to read. Okay. So read. You want to invoke on a recurring schedule? Nope. Do you want to configure layers? Not right now. Do we want to edit this right now? No. Okay, so we've got a Lambda function defined. So I can just go in function here and look at race results resolver. I can open the source folder. I can go into index.js, and I can paste in my code here. So I'm going to copy this code. And so this code it's really straightforward, right? It's using the AWS SDK and calling the DynamoDB client, and then it just uses DynamoDB to fetch our information. But as you can see here, what it's doing is it's doing a query, but it's doing a query on our by driver GSI index. So it's going to get a driver ID from our query. As you saw into schema, we're getting results for a specific driver. So you can get that by looking at event.arguments.driver_ID. And yeah, that's so that's it. It's going to get the condition is to get the results for a driver of that specific ID, and then it's just going to return the information. Yeah, and so it's a really simple function, but it kind of highlights how you can use a Lambda function as a direct Lambda resolver in your AppSync configuration. So let me save that file. Okay, and so now again, we're adding some custom resources to our AppSync API, AppSync resource. So we need to configure them into custom resources.json file. So I'm going to copy that. Let's see. Let me close all the tabs to the right, make it a bit easier to see. And again, we want to go into custom resource.json, and we just want to add these to the end of the resource, to the end of our resources. So what I can do here is just I can make these, I can toggle them like this. So you see what we've got here. And then I add these resources. And again, let me toggle them. So similar to what we did before, we're just adding a new data source. The new data source is the Lambda function. That's what we're calling. And we create the resolver, and we create the role that gives AppSync the permission to call that Lambda function. So you don't want to forget that, right? You've got to give AppSync permission to access resources on your behalf. Okay, now that that's done, and you can see one of the things that I'm doing here, I'm not writing any VTL, right? So I'm creating this resolver, but there's no VTL here. When you're using a Lambda function, providing VTL is optional. If you don't provide any VTL, this is what we call a direct Lambda resolver. Okay, and here's a tidbit, actually. As you are writing your custom resources, if you want to verify that your that your template is valid, you can use the AWS CloudFormation validate template body file. Let me see here. And you can just copy the file path. Let me get the relative path. You can just do this. Oh, I'm into the wrong folder. Okay, make sure you are into the right folder. So let me go back to the top of our application folder. Okay. And you kind of see that it just tells you, okay, this is everything that's in the file. These are your parameters. So it didn't complain about everything. That means the template is valid, and now we can deploy the template. So that's just a tidbit. If you want to verify a CloudFormation template, you can always use this this command, AWS CloudFormation validate template. Okay, let's deploy this. Right? So this will take a couple of minutes to deploy, but once it's deployed, we'll have a Lambda function deployed, and then we'll have our AppSync API updated with a direct Lambda resolver, and then we'll update our application. Here we are. This is just about done. You can see that it's running a couple of last updates. Okay, done. And so now what we want to do is update our application again. So right now, our application only shows the schedule, and we cannot really see the results. So let's change that. Let me go back into account. Did that like this. It's automatically updated. And then you see I can see the driver positions. So for a driver, I can get the information, and you can see I get the information sorted by rounds, and I can see the position for the driver for each round, and I can see how they finished. Right, so finished plus 1 lap, collision, essentially not finished. Okay, so that's pretty cool. And I can do that for every driver as well, right? So, and every one of these queries is being done with GraphQL, and then GraphQL calls our direct Lambda resolver, and the direct Lambda resolver calls AppSync. And you can see some of the details by simply going into the console. So let's look for our Lambda, which is right here. This is it, race results resolver. You can go to monitor, view logs in CloudWatch. And here you just have some straightforward logging. You can see the input that came in when AppSync called the function, and you can see the argument is the driver ID. And AppSync passes a whole bunch of information, like information about the identity, like who called it. And so here you can see that it's passing information about the cognito user. So like if you want to implement something, some type of restrictions or some type of filtering or some type of query based on the cognito user, you could use this information. It sends the header information as well, so this can be pretty useful. And it actually sends the information about the selection set, right? So if you want to do something really specific, if you wanted to do like a really specific query and only retrieve some specific fields from your data source based on what was asked in the selection set, you could actually do that as well. So you have all of this information, and then after getting the data from DynamoDB, it returns it, and you can see all of the information here. All right, so that's using Lambda resolvers, direct Lambda resolvers. Didn't write a single line of ETL. Okay, now there's another use case that we can look at. We looked at connecting your AppSync API to a DynamoDB directly by using VTL. This is a great option to use if you are going to interact directly with DynamoDB. AppSync has like really good integration with DynamoDB. So if you've got like some queries you need to make and all you need to do is go to DynamoDB, you can use VTL. You have your direct Lambda option. If you want to do something a bit more complex, if you've got some specific business logic, maybe you've got to request some data from something running in your VPC or your data center, you can use a direct Lambda resolver. Or maybe you just want to use your language of choice. Maybe you don't want to write VTL and you want to use Node.js or Python or something else. You can just use a Lambda function, a direct Lambda resolver for that. Now, there are also use cases where you need to retrieve data from multiple data sources. Maybe you need to retrieve something from DynamoDB, and then you need to retrieve something from another data source. And keep in mind, AppSync supports a lot of data sources, right? So you could get something from DynamoDB, then get something from Aurora, then Elasticsearch, then Lambda. You can connect to AWS services, and you can take local actions as well, right? So let's say you needed to first retrieve something from your Lambda function, like we just did, but then you needed to do some additional filtering, and you want to do that inline, right? And maybe this is a filtering function that you use across your API for multiple use cases. Well, you could use a local resolver to do that as well. So to do this, AppSync supports the concept of pipeline resolvers. What we've looked at so far are unit resolvers, and we use the word unit because they're contained. They're one, right? It's one resolver running for the request. We have the concept of pipeline resolvers, where you can have one resolver that calls multiple functions to resolve the request, and it calls them in series, right? So it'll call function A first, and then it will call function B pass the result of function A to function B, and then function B will work on that request. If needed, it'll access another data source, and so on. And it can do that up to 10 times. So in a pipeline resolver, you can have up to 10 functions. So they're pretty useful when you want to kind of sequence when you want to access multiple data sources in sequence, and you want to take action based on the result of the previous sequence. So what we want to do next is look at how you can set up a pipeline resolver. So let's go to the last part of our lab for pipeline resolvers. So what we're going to do is we're essentially going to do the same thing where we're returning driver positions for each driver, right? So we can see the driver position for each driver for the races that happened in 2020. But now what we want to do, we want to be able to actually filter that data before we return it to our client. We only want to show the result where the driver has finished. And this is something that we do over and over again. We want to do it in a pipeline resolver. So we want to be able to get the data from a Lambda function first. And then when we get that data, we want to call another function with the result from that query and filter that data before we return it to our clients. So let's do that with our pipeline resolver. So what we're going to do is we're going to add a second result query. So what I'm going to do is I'm just going to copy it. I'm going to make this small for now. And let's go in our schema. I'm going to add this here. So this is essentially the same thing, right? We're just it's the second version of our query, but it's taking a driver ID and returning a set of results. And what we're going to do is let it filter unfinished. Now, we need to add a couple of custom resources to create a new pipeline resolver. Let me show you how that looks, what that looks like. Again, we're going to go in our resources area. Make sure we add a comma here because this is a list of resources. And we filter this down. So what are we doing here? Well, we're creating a query result resolver pipeline. So this is a pipeline resolver that calls two functions. The first one is our getter function that calls the Lambda function to get the data that we need. And the second function is a filter function. This filter function actually doesn't call any data source. It's what we call a local function or a local resolver. It essentially just works locally on the data that you give it. And what we're going to do with it here is have it filter our information. So let's take a look at the pipeline configuration. So it's a function configuration. We give it a name, get results Lambda. The function version is the default is 2018-05-29. That's what you have to use. And here it's just really simple. I'm just telling it, hey, use the Lambda data source that we've already configured, right, in the previous section. So that's fairly straightforward. Second step is our filter. So again, this is filter results. And you can see the data source name here is set to none, which means we don't want to associate this with a data source. Just let it run its code. And then what I'm doing here is I'm providing the request mapping template directly in the CloudFormation template. So I'm not putting the template in. I'm not putting the template in this resolver folder here, which would have then be uploaded to S3. The template is small enough that I just included in the CloudFormation template. And then here's the response mapping template. Same thing here. What we're doing is we're telling it, hey, if the status of a result is set to finished, then add it to our list of items. And then we're just going to return those items as our response. What is essentially going to happen here is that we're only going to include results that have the status of finished. Okay, good. So I save that. Again, you can use this nifty tool here to double check that everything is okay with the CloudFormation template. It is, so no problem. And then what we want to do is simply push it. So that was fairly easy. We already have the Lambda data source configured, so we don't have to configure that again. We set a pipeline resolver. The pipeline resolver is essentially calls those two functions. One thing to those two pipeline functions. One thing to point out for the pipeline resolver configuration. Let's look at it real quick. So okay, it's query.getResults2, and we set the kind to pipeline. If you don't set the kind, it defaults to unit. And then the response mapping template is very simple. We don't need to really do anything here. We're just passing all of the information to our first function. So this is kind of an empty response mapping template. And then we are telling the request mapping template is essentially empty. And then the response mapping template only has return my previous results, right? So we're going to return the results from the filter. The filter is going to return results. When we get to this mapping template, the result will be available in this object called prev. That stands for previous. So that's what's going on here. Okay, let me now push this. We already ran this. And again, let's just push this out. Should take a couple of minutes, but then we'll be ready to go. So that's done. So we've got that deployed. If we look at our application, go here. So nothing's really changed, right? Because we haven't, first of all, we haven't updated the application yet. So you can see I'm still getting other labs that are not finished, that don't have a status of finished. So for example, here for Antonio. So real quick, first, let's look maybe at AppSync. So go into the console. Only have one API here. So you can see I can go to schema, and you can see I have all of my schema information, and you're seeing more information here than you see in Cloud9 because Amplify generates a bunch of inputs and types and fields based on the models that you created in Amplify. But if you search here in query, you'll see, make this bigger, that we have a get results too. And you see that it's associated with a pipeline. And if I click here, you see that there's two pipelines. There's the two functions, the get results Lambda function, the filter results function, right? So when you call get results to, it calls the get result Lambda function, and then it passes the results of this function to my filter results function. And there's no mapping template, it's empty. But what you can see here is that in the response template, it's essentially going to loop through the previous results, so the results that are coming from the get result Lambda function. And again, it's just going to check the status. Is the status set to finished? Then if so, add that item add that result to my list of items. And then when you're done with the loop, return to items. So fairly straightforward. It's easy way to filter. Okay, so let's go back here. And again, we haven't changed anything yet, but what we're going to do is update our application. And the only thing we're really going to do is change our application to use our get results to query. That's the only thing we're going to do. We're not changing the layout or anything like that. But what you will notice is that this information changes if everything goes as planned. So let me, nope, not this one. Expand this, make this a bit smaller, maybe like this. Go to my account page, change my data. Okay, and then let's keep an eye. Okay, and as you can see, I only have finished results now. So only finished results all the way around. And so, yeah, my pipeline function is getting called. And I'm able to call on multiple functions. I'm able to access multiple data sources in one call. Alrighty, so that wraps it up for this lab. So far we've gone through lab 1 where we use data store to access new data sets, and we use data store to manage the access to our data. We didn't really interact with AppSync or GraphQL much. In Lab 2, however, you set up a new data source, a DynamoDB-backed table, and we use that as our existing database. So this was to simulate a scenario where you needed to connect your new application to an existing data source, but you also wanted to do it in a more efficient way. So we did that. We looked at VTL. We looked at using direct Lambda resolvers. And we also looked at using pipeline functions in case you need to interact with multiple data sources in a single query. So this avoids having to do a lot of back and forth and allows you to be efficient with your design. So that being said, thank you very much for joining us today. I hope to see you in Lab 3, where my colleagues will walk you through using Amazon location services and configuring maps in your application. See you then.